Hello class, we are going to be grading your impulse momentum quiz. You have out a red pen. At the top you're going to put corrected by, and then your name, not mine. I'm going to read the question, I'm going to do the question, I'm going to give you the answer. You are going to mark the right answer, give them a +1 if they got it right, and then you're going to correct their work a little bit. So when everyone gets their quiz back, they have an explanation of not only how well did they do, but what they screwed up on. Alright, so which of the following has the greatest momentum? Alright, before I do anything else, I gotta remember that P equals mv, which means that what I'm going to do is I'm going to do m times v and get a momentum. Then I'm going to do m times v and get a momentum, m times v and get a momentum, and m times v and get a momentum, and then pick the biggest one. Or I can see if I can narrow things down a little bit first. So let's narrow things down a little bit. Alright, this one has the biggest mass, but the smallest velocity. Okay, so maybe, maybe not. This one has the smallest mass, but the biggest velocity, so maybe, maybe not. This one's sort of in the middle. And this one is also kind of in the middle. Alright, so I can't narrow it down. I have to use my calculator. So, 2250 times 25 equals... First one is 56250 Newton seconds. The second one is 1210 times 51, giving me 61710. The next one is 6120 times 10 equals 61200. And the last one is 1540 times 38. Which gives me 58520. Alright, well, that one's too small. That one's too small. These are the two highest, and this one's biggest. So the answer is B. If they got the answer B, give them a +1. Alright, next. A baseball is pitched very fast. Another baseball of equal mass is pitched very slow. Which of the following statements is correct? The fast-moving baseball is harder to stop because it has more momentum. Okay, well again, momentum is P equals mv. The first baseball is mv, big velocity, and the second one is mv. So which one's going to have the more momentum? The one that's faster, since their masses are the same. So more momentum. Yeah, that's true. The slow-moving baseball is harder to stop because it has more momentum. No, that's wrong, because the slow one has less momentum. The fast-moving baseball is easier to stop because it has more momentum. All right, well, that one's true, more momentum. The slow-moving baseball is easier to stop because it has more momentum. Well, I know it doesn't. So it's either A or C, because the fast-moving baseball has more momentum. So I've got to figure out, does having more momentum make something harder to stop or easier to stop? And the answer is harder to stop. The answer is A. Please give them a +1 if they got that one correct. Alright, 3. If a force is exerted on an object, which statement is true? Alright, before I do anything else, force exerted on an object. That sounds a lot like my impulse equation, doesn't it? A large force always produces a large change in the object's momentum. Object's momentum? Momentum isn't in this equation. Oh, but wait. That's right. Impulse is also equal to the change in momentum. So they're saying a large force produces a large change. Well, that looks true. Although this word always here bothers me. Okay, here we go. A large force produces a large change only if the force is applied over a very short time interval. So they're saying if this is big, and this is small, this will be big. That doesn't seem right to me. A small force applied over a long time can produce a large change in the object's momentum. It can if the force is really, 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 really big, or this is really, 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 really big. If you want a big change, one of these has to be big, and the other one has to be only a little smaller. So I'm thinking no on that. Small force produces a large change. Usually not. All right, so none of these answers are great. None of these answers are great. What do I do? Well, always. That means no. Ooh. Wait a second. That's an issue. Oh, but remember what I said here? A small force applied over a long time can produce a large change if delta t is really big. So that one's kind of a trick question. All right, 4. 0.06 kilogram tennis ball moving at a velocity of 12 meters per second. The ball is struck by the rocket, causing it to rebound in the opposite direction at a speed of negative 18 meters per second. Notice positive to negative. That represents changing direction. What is the change in the ball's momentum? All right, well, I want that, which is going to be final minus initial. So I need to find what my final momentum is, and I need to find what my initial momentum is, using my momentum equation, m times v. All right, so mass times 12 gives me my initial momentum. I have an initial momentum of 0.72 and a final momentum of 0.06 times negative 18. All right, and that's negative 1.08. All right, so there's that. Got to bring my minus down, equals delta p. Negative 1.08 minus positive 0.72. Negative 1.08 minus positive 0.72 equals negative 1.8. The trick here is that this one is a negative, and it's first. You're doing a negative number minus a positive number. So you should get something more negative, a bigger negative number. All right, give them a +1 if they got that one right. All right, same situation. The racket is touching the ball for 0.05 seconds. What was the applied force? Ooh, interesting. Now, this one is hard, because if you didn't get 4 right, it's impossible to get 5 right. So this one is extra credit. This is extra credit. Here's how we're going to do it. Force times delta t equals change in momentum. Well, I know my change in momentum. I just found it out. It's negative 1.8. I know my delta t. It gives it to me right here, 0.05. All I got to do is solve for f. So that's going to give me negative 1.8 equals f times 0.05. Solve for f by dividing. So I get negative 1.8 divided by 0.05 equals force of negative 36 newtons plus 1. This quiz is out of 4 points. So please write their grade out of 4. 1, 2, 3, 4, 5. So I got a 5 out of 4. All right, please do that. Hand it back to the person who sees it so they can look at it. look at it for 2 minutes or so, then please hand it back to the sub. All right, thank you very much. After this, you have another video to watch on your pre-lab. Go